Good afternoon, grade 9. Welcome to this first lesson of the week after you had your assessments last week. I'm still waiting to hear how it all went, but today we will do revision of the assessment and then we'll continue with our electrical systems and control. We still have a lot of work to do, so I'll be basically giving you answers for the assessment, and I hope that it will help you to see what you were supposed to answer in the assessment. I do realize though that some of you encountered some difficulties, especially with drawings, where drawings are concerned. So I found out that the problems you had with drawings emanate from, oh, you have many problems. Oh, grade 9. Yeah. One of the problems I discovered though is the changing of applications when the submission of pictures. Oh, I see. Oh. Yeah, we are collecting these concerns, these problems that you encountered. They are very important for the development of the school so that we know how we address these problems in further assessments. Yeah, thank you for sharing your experiences with us. Yeah, I know that you encountered problems with the appearance of pictures on your assessment. And I found out that when you are changing from one application to another, some data is lost because of maybe the compatibility of the application that was used by the school and the application that you use on your computer. Even on my computer here, I have different applications. And I do realize that when I am opening a document, I have to choose the same application with which I wrote it. So if I write a document here or a presentation, if I open that with a different application, I see that somewhere I can lose pictures, or I can even lose some data, or some letters will look different, you know, and some symbols, I can lose some symbols somewhere. So that is the first thing that we discovered. But I want us to talk. We need to talk so that you voice out your experiences and then we capture those so that going forward, we will address those ahead of the assessment, right? I'm sorry though that while you wanted to do the assessment, you were hindered by these constraints. And those that didn't submit on time because of some technical difficulties, yeah. We want to hear what those technical difficulties were. Tandy, you didn't submit. Yeah, because on your assessment, you had to see the submit button. Then if that didn't put your test through, I don't know what else maybe you could have done, but we'll look into that. We'll be sharing that with you as we go on. Nosipo, yes, Nosipo, you want to say something? Please chat, please type it here so you can see. Nosipo, you don't think any one of you submitted? Well, okay, I'll talk to the school management about that because I don't want that. I don't want that. Even after requesting editing access, I wasn't able to submit. My laptop said something about an error. Oh. Yeah. Yeah, grade 9. Yeah. I think I'll talk to the school management about that and we'll see what we can do for you, grade 9s. Okay? Don't lose hope, my children. We'll address that. We'll see what you can do about it. I'll come back to you with the feedback tomorrow. Okay, Mpo, welcome. Welcome, Mpo. Welcome into the classroom. Let's see. Let's just revise this assessment. Let's revise this assessment. All right, Nosipo, don't worry. Don't worry now. If it's something that affected all of you, surely the school must do something, but I cannot take that decision. I'll have to present it to them. I'll present it to the school management. And I tried drawing shame, Tando. Oh, all right. Don't worry, my children. Let us go through the lesson for today, and then we'll hand over your concerns and your experiences to the management, and then we'll hear what they have to say. Okay. Right. So I want to share this with you, grade 9s. When you are sitting for an assessment, especially formal assessment, but actually what I'm going to tell you applies to all assessments, please do read the instructions. Actually, let me tell you this. Everything that is written on your assessment is meant for you to read. It's meant for your eyes. From the cover page right to the last page of your assessment, you do need to check your cover page if, I even mean the hard copy kind of assessment, the paper assessment, right? Maybe your question paper. Do read everything that's written there because it's for you. You might miss something very important if you will just maybe skip some of these things. Yeah. Right. You need to ensure that it is the correct paper that you're sitting for, and you need to you need to check the instructions. Instructions are very important because they will tell you how you go about the assessment, right? So this is the mark allocation. So your test was out of 25 marks, so this was the distribution of marks. Okay, so I'll be giving you answers. Please ensure that you jot down these answers. I know you're excited now, you're busy chatting. I would really recommend that you you quickly capture these answers, as I want to fly quickly over that and assist you in seeing how you should have answered. Right, question 1 in section A, 1.1. Okay, what were we supposed to do in question 1? Each of these questions has one correct answer. Choose the correct answer from the options provided. Write the number and letter of the correct answer only. For example, 1.1 is C. Right. 1.1, at this stage of the design process, freehand sketches of the solutions are made. The answer there is design stage. So the answer is D. Please capture that. This material is the hardest in the list below. Correct answer is diamond. Capture that. Question 1, 1.3. This material has a high thermal conductivity. Correct answer is corrugated iron. C. 1.4, vulcanizing is coating to prevent rust. Coating of metal with a thin layer of another metal by electrolysis. Coat iron with zinc to prevent rusting. Correct answer is hardening of rubber, for example, tires. It is vulcanizing. really clear. What happened? A set square used in isometric drawings is set square used in isometric drawings is 30 degrees set square. I hope you have captured question 1. Can I proceed now? Were they? I wonder what happened. Okay. Okay. Does it still look different? Does it still look different? These questions are different from the test. Does it still look different? Really? Wow. Okay. Surely there must be a problem there. We'll see. We'll look into what problem you encountered as grade 9. Let me make a note here to the school management that there seems to be a problem. Okay, just made the note to the SMT. Question 2, match column A to column B. Write only the number of the question and the symbol for the correct answer. And you have your different beams and columns there and their uses. So all you had to do was match the correct description to a specific okay, all right. I've given the SMT this concern. Okay, all right, Kwezi. Question 2 is not different, but the multiple choice was okay, no Sipho. Okay, right. Now, these are the columns and the beams. Okay. Let's match them. This is the correct answer. These are the correct answers. But I want you to understand why these are the correct answers. Let's come back to this question. Right. 2.1, which description fits 2.1? Okay, Mpho, grade 9, could you please just come down? We'll go through the answers, the questions and the answers of this assessment, and then we'll hear what the SMT decides about your assessments, okay? Don't worry this much, okay? Let's just go through these questions, then we'll see. Right, so this 2.1, the correct answer is E. Okay, it's the H profile. This profile is often used as upright supports or columns, for example, in buildings. It resists compression very well and it does not bend easily. Okay. 2.2 is A. A, the I profile. This profile is used for railway tracks. The broad base provides stability. 2.3 is B. 2.3 is B, the U profile. This is lighter than the H profile. It's often used to provide horizontal support, for example, in shelves. The chassis of a truck is normally made from U-beams. Okay. Then this one is C. 2.3 is C. Okay. It is called the angle ion. 2.4 is C. 2.4 is C, is the angle ion. 2.5 is D. Okay, it is the tube profile. So these are the answers. E, A, B, C, D. Yeah. Grade 9, you seem to be having a lot of problems. Okay, right. Section B, draw the staircase below in first angle orthographic projection. Use the provided square grid. You had to download a square part drawn, and then you had to draw it on the square grid. Okay, so this is the drawing that you should have done on the square grid. Or else you could have acquired your own square grid and drawn the drawing of the staircase in first angle orthographic projection. This is how it was supposed to be marked. You have correct positioning of dimensions on planes, 1 mark. Correct alignment of sides, 1 mark. Correct projection of side views, 1 mark. Correct conventions, 1 mark. Labeling of views. So you have 1 mark for putting the top view, front view, and side view correctly. 1 mark for aligning the sides, like this alignment. Okay. 1 mark for projecting, doing the projection, because you project this one from these two. Okay. Right. Let's see. Yo, grade 9. Your side view was a bit different. Yeah, you learn it. It's a practical skill. You have to learn it. Remember, it all starts on this diagonal line here. It must be exactly 45 degrees. It must at an angle, must be at an angle of 45 degrees. This, so that when you project, you come here to this line, then you project upwards. Okay. Yeah, so you have 5 marks for this, for your staircase. So that was your test. You're so worried about your test. You should be, and I promise you, we'll put an end to your worries. We'll take it up with the school management team. Right, let us look at graphic symbols for components. For components. Which question? No, it's not a question anymore. We are going on with our curriculum coverage now. Okay? I was just giving you the answers for the test. We're done with the test now, so we can all start concentrating again. All right? So we are doing electrical systems and control again. And remember, for your circuit diagrams, you must remember your symbols for electronic and electrical components. So this is what I'm giving you now. So that if I give you assessment at any time and I require you to draw a circuit diagram, you will know what symbols to use. Right, graphic symbols for components. Right, we are going on with our electrical and electronic systems and control. This is a generator. Why did we put a magnet here? We put a magnet here so that you can understand that inside a motor, you have coiled up, you have a conductor wound on a soft core, okay? And it has, because it is wound on a soft core, it has a magnet inside. So motors and generators are made from the principle of magnetism, okay? You learned magnetism in grade 7. So a generator converts rotational movement into electricity by using a magnet and coils of copper wire inside. So that is a generator. This is the graphic symbol in your circuit diagram for a generator. Okay. This is the graphic symbol, and this is the conductor, because now you are going to use this in a circuit diagram. So this will be your electric wire or conductor, right? Okay. And another component is the photovoltaic cell. This is a photovoltaic cell, okay? A photovoltaic cell is an input device that changes light energy into electricity, like you have on your solar panels, okay? So how do we draw a photovoltaic cell in a circuit? This is how we draw it. Remember, this is a symbol for a cell. We have our positive terminal and our negative terminal here, and this should represent the light coming into the cell. So it's a photovoltaic cell. It is drawn like this. It takes the shape of a normal cell, but with a circle with arrows coming into it like this, showing that light comes into it, okay? Remember, this comes from your solar panel. So this is how you draw a photovoltaic cell in a circuit. And you have your graphic symbols for resistors. Remember, I told you that we use this one, which is a block, and this is your conductors, or this one, which is a zigzag, and these extensions are conductors. Okay, so both these are acceptable as symbols for resistors. Then you have your variable resistor. A variable resistor is a switch. Let me make an example. Have you ever seen the switch of the volume switch on your radio, or your stove switch? Okay, this is the switch. This is the switch. So it varies from the highest point of resistance to the lowest point of resistance. So when your stove is at 1, actually when your stove is at 0, when it is off, the variable resistor is at its highest point of resistance. But when the stove is on maximum, perhaps if your stove has a maximum of 6 as a unit, so you will be having your stove at 6 at its lowest resistance, okay? So a variable resistor, for example, the dimmer switches. Some people have dimmer switches in their houses for the lights. If you want to adjust the brightness of the lights, you go to a variable resistor on the wall. Okay, it is round. You just adjust the brightness there. That is your variable resistor. Okay, it is like this. Now this is how you draw your variable resistor. This is the symbol for your variable resistor. I'm showing you these symbols because we'll be working with them in our circuits soon. Right. And this one is an electric motor. Right. Remember, a motor is similar to a generator. Okay. A motor has many coils of copper wire wound around an iron core. So they are like the generator, but they work in reverse. Okay, this is an electric motor. This is how you show your electric motor in a circuit. This is the graphic symbol when you draw your circuit diagrams. Right. And this is a heater. This is how you draw your heater. It takes the shape of a resistor, but it is then broken down in those vertical lines. Now, a heater, the resistance wire in the heater gets hot when electrical current flows through it. Remember, we said when there is resistance in a circuit, then the result thereof is heat. Okay, also when there is short circuiting. So when you plug in your heater and current is flowing through the heater offers some resistance in the circuit, and that heats up, and that's actually what you want. You want the heater to generate heat. So that is how heat is generated. It is generated by the resistance of the wire in a heater. Okay. Then that's it about the new graphic symbols. I have taught you graphic symbols before, but I'm just bringing in more and more. Okay. Now, the formula for Ohm's law, you've done this with me already. You've done it twice, but I'll always be reminding you of it so that you don't forget it. This is how you calculate, do calculations in Ohm's law. Current equals to voltage divided by resistance. Resistance equals to voltage divided by current. And voltage equals to current multiplied by resistance. So always remember this. Okay. Now I'm just going to revise again with you the understanding of Ohm's law. Okay. What does Ohm's law say will change in a circuit when the resistance is kept constant but the number of cells in series is increased? What will change? When you increase voltage, what will change? Able, what will change? Current, very good. Current changes with voltage. How will the current change if the voltage supplied by the battery of cells is kept constant, but the resistor is replaced by another resistor with a low resistance? What will change? How will the current change? Come, grade 9. The current, the current will increase. Current, what will increase? Current will increase. Okay, let's see. You're correct. The current will increase. How do you describe the relationship between the current and the voltage in a circuit? They are directly proportional. They are directly proportional. You're correct. That's correct. They are in direct proportion with each other. You're correct. Okay. Which of these changes will cause the current through an electrical circuit to decrease? Write down the letters of the statements that are correct. Okay. A decrease in the voltage, a decrease in the resistance, an increase in the voltage, an increase in the resistance. What is it that will decrease the current amongst this? A and D. Correct. An electrical circuit has 1.5 volt cells in series that is connected to a lamp and a resistor in series. Which of the following things would cause the lamp to shine less brightly? Write down all the letters of the statements that are correct. B and D, correct. Decrease in the voltage of the battery and increase in the resistance. Okay, I hope you all understand. You all understand the relationships of the variables in Ohm's law. I think you do now. Is anyone still confused as to the relationship, what the relationship is between voltage, current, and resistance? You now all understand Ohm's law, right? Okay. Now, let's look at switches. A switch controls the electric current by closing or opening the circuit. There are various types of switches that control the circuit in different ways. In this lesson, you will learn about manual switches that a user can turn on or off. Now, you know that there are automatic switches, like the switch that maybe you find in your fridge. When you open the door of your fridge, the light automatically comes on. Okay, now that is automatic. You don't open the door of the fridge and go to a switch and turn it off, but the switch to the lights has been made automatic, okay, linked to the closing and the opening of the door. Like again in your car, when you open the door of your car, then the lights turn on. Now that's an automatic switch. But the switches that you're going to start with now are those that are manual, that you have to turn on and off with your finger. Right. I've shown you the graphic symbol. You've seen this circuit before. It's a simple doorbell circuit. And you have seen that this is a push switch. When you press the doorbell, then this buzzer goes off. This is a single pole, single throw switch. This is the pole, one throw. Single pole, single throw. Now this is a single pole, double throw, because you see two throws there. Right. Now, what connection do you see here? Is it a parallel connection or a connection in series? What connection is this, grade 9? Grade 9, hello. This is a parallel connection because these two lamps are not connected in one line in a circuit. Okay, lamp A has its own line of connection. Okay, And what is the power source? What is the value of the power source here? What is the voltage of this circuit? What is the voltage of this circuit, grade 9? The voltage is? What is the voltage of this circuit, grade 9? The voltage is 4.5 volts. How do I know that? I know that this 1 unit here is 1.5 volts cell. So this is another 1.5 volt cell and another 1.5 volt cell. Okay? And this is the positive terminal of the battery. This is the negative terminal of the battery. Yes, yes, Jay. It is 1.5 volts times 3. So it is 4.5 volts. Okay. I'm just assessing if you did master the graphic symbols that we did. Okay. So this switch here, what kind of a switch is it? Grade 9? What kind of a switch is it? It's a single pole double throw. We have one pole, we have two throws. Single pole double throw. This switch is connected to a parallel circuit, to a circuit where two lamps are connected in parallel. I can ask you to draw this cell. I can ask you to draw this circuit, I mean. If I can give you the value of the power source and I say, draw a circuit diagram with the following components. Power source, a 4.5 volts battery connected in series, and switch, a single pole double throw switch with two lamps connected in parallel. You must be able to draw this circuit diagram. That's why I'm asking you if you recognize the graphic symbols of the components in this circuit. All right. Now, when you look at the flow of energy in this circuit, you will see that when the switch is closed, okay, when a switch is closed, it is actually on. When the switch, the pole is connected to throw A, the current will be moving to this lamp above. When the pole is connected to throw B, the current will be moving to this lamp that is below. So you must be able to recognize the flow of electrons in this circuit. Okay? You must understand, you must be able to draw it from the specifications. You must understand the flow of electrons. Okay? You must be able to analyze it in the operation of this switch. That is the single pole, single pole, double throw. Now let us look at another circuit with the single pole double throw. I said this is an application where, for instance, you can use this switch to control a light, this light, one light. You see this circuit has one light, but you can switch on this light from switch 1, or you can switch it on from switch 2. For instance, a house with a long passage, okay? Or a house with a staircase where one switch will be in the ground floor, and the other switch will be in the first floor. And both the switches are switching on this lamp. Okay, so that's another circuit with the illustration of the single pole double throw switch. Now you have your double pole double throw. You have double pole, 2 poles here, and double throw here. Now, you must look at how these switches can operate. This switch, it's one switch, but it has a double pole and double throw. They are used to reverse the direction of current through a circuit. So they are useful in applications such as automatic car gates. Okay, the circuit diagram below shows how a double pole, double throw switch can change the direction of current through an electric motor. Okay, right. How the electric motor runs. Right. This is showing how current can go forward and it can reverse. Opposite direction when the current can go the opposite direction when it passes through terminal from terminal M2 to M1. From terminal M2 through the motor to terminal M1, right? 2, 4. There, 2, 4. Right? And then to 5, then it goes, where am I clicking? It goes to M2, then to M1. And then from M1, it moves down to 6. Through the bottom part, and then from 6 to 2, when the pole is on this throw. When you close here, it goes to 2 and to the negative terminal of the battery. So these switches, they allow movement of current from different sides to different sides of the circuit through different motors. When this one closes, when this one switch closes and the other opens, then the current is alternating. Okay? So that is the operation of your switches. Okay, I repeated this lesson because I could see that on Friday you were also caught up in the problems of your assessment, and I really want you to understand these circuits because you may be required in an assessment to draw these given specifications, and from those specifications to draw these circuits. Okay, illustrate how the current moves in an operation of these different switches that you have been shown. Okay, thank you, grade 9. As I promised, I will take up the matter of your assessment with school management. I cannot make decisions on my own, but I will come back with the feedback to tell you what the school has decided. Have a lovely evening. Thank you very much.